Okay. Hello. Good morning, good afternoon, good evening. Welcome back to another Coding Not So Damn Get a Job. This is 142. I'd like to apologize for being MIA for almost 2 weeks. I was sick for almost a week more, like a week and a half, I guess. And I guess I wasn't just, sorry, I wasn't feeling too well after the New Year's, and then yeah, I just couldn't really do any stream, and I don't know, but I'm healing and trying to yeah, relearn again. And during the week I got sick, I've been thinking a lot on the job search and things like that. And I know, I think a few streams ago I mentioned that okay, I want to finish the JavaScript DSA, and then just um yeah, I guess let's just do that. Although I've been thinking a lot on how is it, am I truly going to get a job if I mean, like, the projects and everything are still okay, but I guess the next step that I want to do is I kind of need to improve the LinkedIn, improve my CV again, add some of the latest projects, and yeah, probably go from there. So yeah, today, to be honest, I don't really want to do the essay. I don't really want to do. I don't know what to do, to be honest. I just feel like I should stream something after almost 2 weeks, but yeah, I don't know. I guess we should just force and just go with it. Yeah, let's go. Hello.
My name is Vishwa.
Sai Krishna, hello, welcome. It's been a while.
For our next problem, we're going to look at the climbing staircase problem. Here is the problem statement. Given a staircase of n steps, count the number of distinct ways to climb to the top. The constraint is that you can either climb one step or two steps at a time. For example, if you have one step, there is only one way to climb it. If you have two steps, there are two ways to climb them.
Hello,
One at
hello.
a time or two steps at once. Similarly, if you have three steps, there are three ways to climb. One at a time, one and then two, or two and then one. Similarly, if you have four steps, you have five ways to climb to the top. One at a time, one, and then two, one, two, and then one, two, one, and then one, finally, two steps at a time. Hopefully, you now have a good understanding of what we are trying to count. Now, let's understand the approach we're going to take to solve the problem. And to be honest, this is something we can derive from the constraint. At any given time, you can either climb one step or two steps. Which means, if you have to climb to step n, we can only climb from step n minus 1 or n minus 2. There is no other way. So what we have to do is calculate the ways we can climb to n minus 1 and n minus 2 steps and add the two. That will give you the ways to climb to the nth step.
At any given time, you can climb either one steps or two steps. If you have to climb to step n, we can only climb from step n1.
So, climbing staircase of n staircase of n minus 1 plus climbing staircase of n minus 2. And this seems familiar, doesn't it? It is the pattern for the Fibonacci sequence. Let's verify the formula using the previous slide. We know that climbing the first and second steps are fixed at 1 and 2 ways respectively. Third step would now be sum of 1 and 2, which is 3. The number of ways to climb fourth step would be the sum of 2 and 3, which is 5. So the number of ways to climb n is equal to the number of ways to climb n minus 1 plus the number of ways to climb n minus 2. Hopefully, you're able to understand how to solve this problem. Please pause the video and try solve the problem. Let's discuss the solution together.
It's been at the halt because I was sick, and that's why I've been streaming, or at least like studying, for the past almost 2 weeks. So yeah, it's been terrible, to be honest.
Next video. In this video, let's write the code for our climbing staircase problem. Back in Replit, let's begin by defining the function signature. Function climbing staircase, parentheses, curly braces. The function will have one parameter, n, which is the number of steps in the staircase. Now we do have some constraints we can use to get started on the solution.
That
We know that the number of ways to climb one step is 1, and the number of ways to climb 2 steps is 2. So let's create an array. Const number of ways is an array 1, 2. Let's now return number of ways of n. But here's the thing. Our staircase starts with at least one step, but an array starts at index 0.
So at minus 1.
To equate the two, we have to return number of ways of n minus 1. If we now log climbing staircase, passing in 1 and 2, run the code, we see 1 and 2 respectively. And we know this is the right answer. Now let's add the logic for n greater than 2. We know that the number of ways to climb n steps is equal to the number of ways to climb n minus 1 steps plus the number of ways to climb n minus 2 steps. We can use a for loop and implement this logic. For let I is equal to 2, I less than or equal to n, I plus plus, and in each iteration, number of ways of I is equal to number of ways of I minus 1 plus number of ways of I minus 2. We start at 2 since array index starts at 0. If we now add additional logs for n is equal to 3, 4, and 5,
It's gonna be...
run the code, we see the expected values returned. 1, 2, 3, 5, and 8. Our code works as expected. Now what is the time complexity?
of n,
Well, we have one for loop.
right?
So the time complexity of our climbing staircase function is O of n, or linear time complexity. Alright, for our final problem in this JavaScript algorithm series, let's take a look at the Tower of Hanoi problem in the next video. Thank you for watching. Make sure to subscribe to the channel, and I'll see you in the next video.
Oh, after this, the data structure. Okay.
In this video, let's learn about the Tower of Hanoi problem. Tower of Hanoi is a mathematical puzzle where we have 3 and a number of disks of various diameters. The objective of the puzzle is to move the entire stack to the last rod, obeying the following rules. Only one disk may be moved at a time. Each move consists of taking the upper disk from one of the stacks and placing it on top of another stack or an empty rod. And lastly, no disk may be placed on top of a disk that is smaller. Let's begin by understanding the idea behind the solution. For that, we are going to visually solve the problem when the number of disks is 2 and number of disks is 3. Let's start with 2. You can see that we have 3 rods named A, B, and C. On rod A, we have 2 disks. Now, how would we move the disks from A to C, ensuring none of the rules are broken?
I forgot to write down the rules. Okay.
Here is how. First, move the smaller disk to B. That is the topmost disk. Next, move the larger disk to C. Finally, move the smaller disk from B to C. Although we don't have a pattern yet, I want you to keep in mind the following steps. First, we shift n-1 disks from A to B. We then shift the last disk from A to C. Finally, we shift n-1 disks from...
Okay, so first, C.
B to C. If you've understood this well, let's do the same exercise when the number of disks is 3. I have the steps from the previous slide on the bottom right for reference. As you can see, we have the same 3 rods A, B, and C. Begin by shifting the smallest disk from A to C. Next, shift the medium-sized disk from A to B. Next, move the smallest disk. At this point, we have shifted n-1 disks from A to B. Step 2, shift the last disk from A to C. Let's move it. Third,
B to A?
Shift n-1 disks from B to C with the help of A. So shift the smallest disk to A, shift the medium disk to C, and finally, the smallest disk to C. Hopefully, you're able to understand how to go about solving the problem. Our code is going to be an implementation of the 3 steps that you see here.
Okay.
And we will be using recursion. If you would like to try solve the problem, please pause the video.
Yeah, no, I'm not gonna do that.
The solution together.
This is man, this is hard. I'm trying to understand each of the algorithm and it's just like, huh? How?
Let's write the code for our Tower of Hanoi problem. Back in Replit, let's begin by defining the function signature. Function Tower of Hanoi, parentheses and curly braces. The function will have 4 parameters. N, which represents the number of disks, from rod, to rod, and using rod. These represent the 3 rods we will be using in our code. Let's call this function with the right arguments. Tower of Hanoi, the number of disks is 3, and we want to shift the disks from A to C using B. As you can see here, from rod A to rod C using rod B. Now, I mentioned our solution is a recursive solution. Let's begin by identifying the base case. And that would be our step 2 in the slide. Move the last disk from A to C. So, if n is equal to 1, console log disk 1 from rod to rod. And then we simply return from the function. From rod is A and to rod is C. Moving the disk from A to C is all we need when there is just one disk. Next, let's handle the recursion. If we go back to the slide, I mentioned step 1 is to move n-1 disks from A to B using C.
What does using
So
C
what we
mean?
have to do is call Tower of Hanoi, passing in n-1 disks from rod, using rod, and to rod. So move n-1 disks from A to B using C. We log that to the console. Move disk n from rod to rod. Finally, if we go back to the slide, you can see step 3 is to shift n-1 disks from rod B to C using A. So we once again call Tower of Hanoi, passing in n-1, but this time using rod to rod from rod. Here, using rod is the from rod, which is A. To rod is the to rod, which is C. And from rod is the using rod, which is B. So shift from B to C using A. This is our solution to the Tower of Hanoi problem. Let's run the code and make sure it works. We have our log statements, so let's compare them with the slide from the previous video. First, move disk 1 from A to C. So move the blue disk from A to C. Next, move disk 2 from A to B. So move the green disk from A to B. Next, move disk 1 from C to B. So move the blue disk from C to B. Next, move disk 3 from A to C. So move the orange disk from A to C. Next, move disk 1 from B to A. Move the blue disk from B to A. Move disk 2 from B to C. Move the green disk from B to C. Finally, move disk 1 from A to C. Move the blue disk from A to C. All the disks have been transferred from rod A to rod C while obeying all the constraints. Our code works as expected. Now, what is the time complexity? Again, we are not going to derive the time complexity, but instead I'll help you understand with a pattern. If you're interested in deriving it, I would suggest you Google master theorem and read about that. It helps calculate time complexities where recursion is involved. Now then, let's understand the pattern. If I run the code with n is equal to 1, we see one statement. N is equal to 2, we see 3 statements. N is equal to 3, we see 7 statements. So this follows the trend of 2 power n minus 1. We can approximate this to 2 power n. As the value of n increases, the number of statements to execute is 2 power n. So time complexity, big O, is equal to O of 2 power n.
Oh, okay.
With that, we have come to the end of the series on algorithms with JavaScript. In the next video, I want to go over some terminology you should be familiar with, and I will also suggest where to go from here. Thank you for watching.
I don't know if I should just do the... Yeah, let's do the data structures after this.
Alright, for the final video in this series, I want to recap what we've learned, talk about the algorithm design techniques you should be aware of, and what you should be learning next. In this course, we have primarily learned about math, search, and sorting algorithms along with their time complexities. Let me tell you, these topics are the 3 pillars when learning algorithms with any language. It is also what would be taught when you enroll into a computer science degree or boot camp. As a front-end developer, you might not use these algorithms in your day-to-day work, but it is expected that you know them and are potential topics of discussion during an interview.
Yeah.
Hopefully, you now have a good understanding of these fundamental topics. The next topic of discussion is about algorithm design techniques. An algorithm design technique is a general approach for implementing an algorithm. Let me now list down some of the popular algorithm design techniques that you as a developer should be aware of. First, we have brute force, which is a simple and exhaustive technique that evaluates every possible outcome to find the best solution. An example is the linear search algorithm we had a look at earlier in the series. The next technique is the greedy approach, where you choose the best option at the current time without any consideration for the future. Now, we haven't discussed any algorithms that use this technique, but a few examples are Dijkstra's algorithm, Prim's algorithm, and Kruskal's algorithm, which are all applicable on a graph data structure. More on graphs in the upcoming data structures course. The next technique is divide and conquer. In this technique, you divide the problem into smaller subproblems. Each subproblem is then solved, and the partial solutions are recombined to determine the overall solution. We've had a look at quite a few examples with this technique. Binary search, quick sort, merge sort, and the more recent Tower of Hanoi problem are all examples of divide and conquer. The next technique is dynamic programming. This is similar to divide and conquer in the sense that you divide the problem into smaller subproblems. However, the difference is that you break it down into smaller but overlapping subproblems.
Okay.
In such cases, you store the result and reuse it for the same subproblems. This is called memoization and is an optimization technique that improves the time complexity of your algorithm. The Fibonacci sequence and climbing staircase problems are good examples for this technique. The last technique is backtracking, which is similar to brute force. You try generate all possible solutions, but each time you check if the solution satisfies all the given constraints and only then proceed with generating subsequent solutions. If the constraints are not satisfied, you backtrack and go on a different path to find a solution. A popular algorithm that uses this technique is the n-queens problem, where you have to place n number of queens on a chessboard so that no 2 queens threaten each other.
Break down into smaller but overlapping.
There are a few more techniques out there, but from a beginner's perspective, this list is a good starting point. Now, for the final part, let me tell you how to proceed from here. My advice would be to solve a few problems and determine their time complexities. You have some math algorithms like finding the greatest common divisor using the Euclidean algorithm, or finding permutations and combinations of a list of numbers. You can also try finding the longest common substring in a given string. Another great algorithm is the knapsack problem, which has practical applications that you might more relate to. Google about these problems at your leisure and learn how to solve them. Once you do that, your next step should be to watch the upcoming data structures course on this channel, which will cover all about data structures in JavaScript. That will help solve some problems related to trees and graphs which we haven't discussed in this series, but more importantly, it will give you the knowledge to write better code at work or help crack that coding interview round. There is a lot more to learn, and I am excited to share that with you in the next series.
Ooh, okay.
But for now, thank you for watching. Please do consider subscribing to the channel, and until next time, take care. Hey everyone, my name is Vishwas, and welcome to a brand new series on JavaScript data structures. In this introductory video, we will briefly go over the what and why of data structures, and also talk about the prerequisites to get started. Before we begin, I want to talk about 4 points. First, this course is a continuation of the JavaScript algorithms series. If you haven't watched that playlist, please do so before proceeding. It is not a must, but is something I highly recommend for continuity. Second, different programming languages have different data structures. Our language of choice in this series is JavaScript. Third, it is possible to implement a data structure in a few different ways. We will be learning what I feel is the simplest way. If you're referring to more than one resource for learning about data structures, please don't be alarmed if you find 2 different implementations. My advice would be to pick the solution which makes sense to you. Finally, please do not memorize the implementation, as that will primarily help you only score marks in an examination. Instead, try to understand the data structure and, more importantly, code along with me, as that is the best way to learn. Alright, let's begin.
Let's begin.
What is a data structure? In very simple terms, a data structure is a way to store and organize data so that it can be used efficiently. If I have to elaborate, I would say a data structure is a collection of data values, the relationships among them, and the functions or operations that can be applied to that data. Now, why do we need to learn about data structures applied to that data? Now, why do we need to learn about data structures? If you think about it, almost every application we build involves data that is modeled in a certain way. To efficiently manage the data, you need data structures. Imagine walking into a library only to find out there is no efficient organization of the books and they are sorted randomly. It would take you hours to find a book, and you might never walk into that library again. The same concept translates to the code you write. The difference between a function taking a few milliseconds versus a few seconds or even minutes comes down to the selection of the right data structure. Data structures help you solve problems in a more efficient way, both in terms of time and memory. Learning about data structures also helps you gain a more profound understanding of things you're already aware of. For example, the document object model, which is what we see an HTML page represented as in the browser, is a tree data structure. The browser back and forward buttons, well, that is managed using a stack data structure. Operating systems use a queue data structure for job scheduling. Data structures are everywhere, and having knowledge about them can only help you in every step of your career. If you're a beginner in programming, if you're a software developer from a non-computer science background, or if you're a front-end developer looking to clear those algorithm and data structure interview rounds, this course is for you. Now that we understand the what and why of data structures, let us go over what we will be learning in this series. First, we are going to go over the built-in data structures in JavaScript: arrays, objects, sets, and maps. We will then use the built-in data structures to create custom data structures. We will look at stacks, queues, circular queues, linked lists,
linked list.
trees,
Holy,
and
okay.
finally, graphs.
Here we go.
Of course, you'll have a solid understanding of the fundamentals of data structures in JavaScript. Next, let's talk about the prerequisites. First is modern JavaScript. If you're new to JavaScript, please watch my crash courses on the fundamentals of JavaScript, the advanced topics in JavaScript, and also the video on the important concepts in ES 2015 and above. JavaScript is the language we will be using, and you must know the fundamentals. Second is the JavaScript algorithms playlist, which, as I already mentioned, is sort of part 1 of this overall playlist on algorithms and data structures. Having said that, I would say please do watch at least the first 5 videos in that playlist if you don't have the time to watch the entire playlist. The concept of time complexity and big O notation are important in this playlist, which I have covered in those 5 videos. The code pertaining to the necessary videos will be in the description box down below. There is also a sign up link to sign up for free and fork my code, and you can make the necessary changes when you're coding along with me. Alright, with these points in mind, let's get started with the built-in data structures in the next video.
Let's go.
Welcome back. For our first built-in data structure, we're going to look at arrays in JavaScript. I understand if this is a bit too simple to start with,
No,
but stick with me
it's
till
okay.
the end as I want to discuss the time complexity of common array operations, which are very important to keep in mind.
Do you have dynamic paging? What do you mean by dynamic paging? Is it pagination or is it something? To be honest, I am not entirely sure. Okay, that's not what I meant. Dynamic paging refers to a process of dividing and loading the system into manageable pages or chunks in real time. Is it this one? Like, is it this pagination
With the
or?
characteristics. First, an array is a data structure that can hold a collection of values. Second, arrays can contain a mix of different data types. You can store strings, booleans, numbers, or even objects all in the same array. Third, arrays are resizable. You don't have to declare the size of an array before creating it.
In JavaScript at least, right?
Fourth, JavaScript arrays are zero indexed and the insertion order is maintained.
I mean a website that should change depending on user. Ah, okay. Okay, so what in my understanding, that means you need some sort of database, right? That means, because that means you need to fetch certain data and it shows to like different user. Is that what you meant? I think that's what you meant, right? At least it's my understanding as well. The thing is, this is probably terrible, but I've only know how to do that when using like libraries or framework. So if it's just regular HTML or vanilla, I don't know how. I know that's terrible. But yeah. Is that what you meant, Ronnie?
The first element of an array is at index
Thank you,
1.
nonetheless. Okay, I guess the thing is on in my experience, the only way I've done that is using libraries or framework, and then have a database, and that there is like a, how would I say it? Like an authentication setup where uh, you need to log in, sign up, and then from there, the date whenever the user requests to go to that page, and after they like log in, the yeah, it will like fetch the database based on that username and password, and like yeah, all the whole authentication setup. And then yeah, it fetch the data, like maybe select from user, or select from um yeah, select from username where name is equal to the input from the login page. And then like, oop, okay, you're allowed, since you have the username and password, you're allowed to see the data of this user, if that's what you meant. At least that's from my understanding. Like for example, um okay, so I been building this like villa management app. And for example, I have some username, sorry, I have some account made and custom made. So if I enter the username and I enter password, that means that account belong to that person. Let's just say my name is Erdi and I have the Erdi account. I could just enter the username Erdi, the password Erdi, since I already signed it Erdi as a username in the database. If I click logged in, then in the like the user menu, it will be Erdi, if that's what you meant. I think that's what you meant. Hopefully.
Is at index 1, and so on. And the last element is at the index value of the array's length property minus 1. Finally, arrays are iterables. They can be used with a for-off loop. These are points you might already know, but I wanted to include them to help contrast with the set data structure, which we will learn shortly. Alright, now that we understand the characteristics, let's look at an example in code. For the series, we will be using Replit as our code editor. You can create a free account by clicking.
I have a super base and I also have authentication, but the problem is most of it's AI and I want to learn the code instead of relying on AI. Okay. Okay. So, okay, 1 second. I have tried. Okay. What do you use for the front end, if I may ask? Because I remember trying to use Superbase, but I don't really like Superbase, so I kind of just used Postgres. But okay, let me look. Yeah, if I'm not mistaken, I tried to watch this one.
If you want to know what the future of YouTube looks like, there's one.
Was it from Pedro or is it someone else? Yeah, I forgot. But back end, right? Okay. Oh, okay. I forgot his name. I forgot his name. I really like. He has like a 4 hour, 5 hour video on backend. So I forgot his name. There we go. He has like, yeah, I think I remember like watching halfway through it, but I didn't really finish it. But this one uses Node.js. But if you want to look for the Figma one, sorry, Superbase. I think I was watching who? Yeah, who was? Is it Pedro? I think it's Pedro. I think you can check this one if you want to still use Superbase. Yeah. Let me grab that. Okay. Holy, this guy is insane. Okay, maybe I should follow this. Like, oh my god, he is crazy. Okay, would you mind? Let me give you that pop-up chat. You can check out this one. I don't know if you by Pedro. Pedro has a very easy to follow and like yeah, really good. He has a lot of project that uses Superbase, so give that a try. Pedro Tech, I really like Pedro Tech. Okay.
Clicking on the link in the description down below. That should give you access to fork the source code and play around with it when necessary. To follow along, I would suggest you create a Node.js template and it will make it done. Const array is equal to 1, 2, 3. You can also add a string, as arrays can contain a mix of data types. To access an element, we use the index.
The index, okay.
If I console.log array of 0,
it's gonna be 1, okay.
Run the code.
That one I understand.
Element in the array, which is 1. Let's look at a few methods on arrays. To add an element to the end of the array, you can use the push.
The small James one or that one? Because if you want to use, I think if you have Superbase, you wouldn't need any like Express or like any like backend. If you use Superbase, because they have their own like REST API, right? But if you want to learn how to do it, I think small James, the Node.js is very good. Small James, yeah. For this one, the backend one, it is yeah, I think this one uses Node.js, Express, and Postgres. Yes.
Method array.push
It's gonna
4. To iterate over all the elements in the array, you can use the for of loop. For const item of array console.log item. Run, and this will print all the items in the array. 1, 2, 3, Vishwas, and 4. If you want to add an element at the beginning of the array, you can use the unshift method. Array.unshift 0. Rerun, and we see 0 is now the first element. You can remove an item from the end of the array using array.pop, and you can remove an item from the beginning of the array using array.shift. Rerun, and we see the two elements which were added, that is 4 and 0, have also been removed. These are the basic array methods. Apart from these,
hey, thank you. Yeah, I learned a lot from the channels. I hope you can understand or at least like get your application working, because yeah, good luck, man.
like map, filter, reduce,
Hello.
concat, slice, and splice. I want you to pause for a minute, Google these methods, and understand at a very high level what they do.
Okay, let's do that. So let's The map method of array creates a new array populated with the result of calling a provided function on array element in the calling array. Okay, that's actually kind of confusing. Hello, Jigar. How are you? So it's gonna okay. The language that the create a new array populated with the result of calling a provided. How can you make it like easier? But like what's okay? This one is in German. That's even worse. This is not the map. Okay, array map. Yes. Oh god. Okay. Okay, it's in German. That's even worse. Okay, never mind. So it's just gonna apply the callback function to the whole element inside of the array, I guess. Okay. Array provides a lot of methods. We already know methods. Okay, so we have push. That's item to the end. We have unshift. Adds item to the beginning. Pop is extract. What does extract supposed to mean? Like remove? Okay, I'm just gonna ask like GPT for this. Like give me in a language that human could understand. Okay, this is me. Add or remove, yeah. Push is like putting it at the end. Pop is removing it from the end. Let's start from the array. Yes. Unshift adds it to the beginning. Push adds it to the end. Shift removes it from the start. Yeah. Now transform each element into new value. Okay. I see. It doesn't mutate the array, but it returns a new array that match that condition. Okay. Reduce array to a single value. Okay. Execute a function for execute. Okay, so okay. This one is self-explanatory. Like fine. And then the find index. Okay, includes check if value exists. Score. Wow, okay. Extract parts of new array. Okay. So we have slice and then we have splice. Add to remove element. Okay. The first. So the first is the index of the element that you want to change. On what is this one? Oh, I don't know. Okay. Sort element. Yeah. Okay. Always pass a compare function. Merge array using concat. Return the array. Okay. Cool.
Now, if you finish that task, let's discuss the worst case time complexity of some of these common methods and operations. When it comes to arrays, it is very important to maintain the appropriate index anytime we perform an operation. And that is what we have to consider when determining the time complexity. If you insert or remove an element from the end of the array, the time complexity is constant. However, if you insert or remove from the beginning of the array, the time complexity is linear. This is because the index has to be reset for every remaining element in the array. Accessing an element is constant time complexity, as fetching the first element is no different from fetching an element at position 100,000. Searching for an element is still linear time complexity, as the element can be the last one in the array. Now, given these time complexities, following is a list of the common array methods with their time complexity.
Hello, Telnet. Hey, bro, I use Emacs now. How is it? I've only seen a few videos of people using Emacs, so I'm not entirely sure or like know much about it. So, what do you think about it? About Emacs and yeah? Access an element is O of 1. Okay. Search is also search is O of n. Push pop is O of 1. Oh, because yeah, makes sense. You just slice and splice. O of n.
Shift, unshift, concat,
How is
slice,
the
and splice
Emacs
are
experience?
linear. For each, map, filter, and reduce are also linear. And this is very important.
For each map, filter and reduce is O of n.
When solving a problem, you might use dot for each or dot filter, and the callback function would also contain a for loop. In such a scenario, your time complexity is quadratic, and the interviewer might not be happy with that.
Of course.
So that is a quick overview of the built-in array data structure.
Cool. Okay.
In the next video, let's take a look at objects. In the previous video, we had a look at arrays in JavaScript. In this video, let's take a look at objects. Let's begin with the characteristics. First, an object is an unordered collection of key-value pairs. The key must either be a string or symbol data type, whereas the value can be of any data type. If you don't know what symbol is, don't worry about it for this series. It is something to take away as homework. Second point, to retrieve a value, you can use the corresponding key. And this can be achieved using the dot notation or bracket notation. Finally, unlike an array, an object is not an iterable. You cannot use it with a for-off loop. Alright, now that we understand the characteristics, let's head back to Replit and look at an example in code.
The Emacs is awesome. At the point where it doesn't become distracting, I become productive in it. Ooh, nice. Do you have like an example of it?
In between the curly braces, 25. If we console log the object and run the code, we pretty much see the same representation in the console. To access an element, we can use the dot notation or the bracket notation. So console.log object.name and console.log object of age. Run the code, and we see an error, age is not defined. To fix the error, make sure age is a string, not a variable.
So you can access it using the...
And we see the two values in the console, Bruce and 25. The bracket notation is primarily used when the object key contains spaces or hyphen. For example, if we have a third property, key 3, we access the same using bracket notation. Run the code, and we see the output true. This is not possible with dot notation. Now the dot or bracket notation can also be used to add key value pairs to the object. For example, object.hobby is equal to football.
Like, I want to see like how...
console.log object, run the code,
because I know people customize it to like
and we see the
crazy stuff, right? So like, how are you customizing it, or like how are you using it?
About deletion, you can delete a key value pair with the help of the delete operator. So delete obj.hobby.
It's gonna delete it.
Code, and we don't see that key value pair anymore. Finally, it is possible to add functions as values. So we add a new key, say my name, and this is set to a function.
Okay.
Console.log this.name. Here, this refers to the object obj. So if we invoke obj.sayMyName with parentheses,
it's gonna
run the code,
console log Bruce.
We should see the corresponding log statement, Bruce. Change name to Heisenberg, and we see the log changes. This is pretty much the basics of working with objects in JavaScript. Apart from what we have seen here, we have methods like .keys, .values, and .entries, which return an array of all the keys, the values, and key value pairs present in an object, respectively. I want you to pause for a minute, Google these methods, and understand them better with an example. Alright, if you're done with that task, let's discuss the worst case time.
Okay, let's find object.keys. I think that's just gonna print out the like the keys, right? And then object.values is gonna print out the values. The entries, I'm not sure. Entries, yes. So we can go to object keys. Okay, let's do MDN with its cryptic knowledge. I think we should just wait, right? Give it a test console.log and then like obj.keys. Ah, sorry, no. We need to do object.keys and then like obj. Okay, and then we can duplicate the tab and then we can do node object.ts. Yeah. Name age hobby. Yeah. Okay, cool. What about object values? It's gonna print out the values. So I think if we do that, and then we can do cool. Okay, nice. And then I think we could just figure it out. Let's see if it what does the entries is. String keyed property key. Ah, it's just gonna print array of both the keys and values. Okay. Okay. Okay, understand it. Understand. Okay, okay. Port to the Android. What do you mean, Emacs can run on Android? Huh. Okay, cool.
Complexity of some of these operations. Since an object is a collection of key-value pairs, if you want to insert or remove a new key-value pair, the time complexity is constant. No matter how many properties exist in an object, it takes the same amount of time to insert or delete a key-value pair. If you want to access a value given a key, the time complexity is once again constant. Accessing object.name does not depend on other properties present in the object. However, if you want to search for a value in an object,
when?
the time
Okay.
complexity is linear. To search for a value, in the worst case scenario, you might have to search all the properties present in that object. Finally, object.keys, which returns an array of all the keys, object.values, which returns an array of all the values in an object, and object.entries all have linear time complexity. Again, I can't stress enough how important it is to remember the worst case time complexity for basic operations. You will use them a lot, and misunderstanding the time complexity can lead you to writing code that suffers in terms of performance. Alright, that is pretty much the basics of working with objects in JavaScript. In the next video, let's take a look at the set data structure, which was introduced in ES 2015. Thank you for watching. Make sure to subscribe to the channel, and I'll see you in the next one.
Harunda Mahe, hello.
In this video, let's take a look at the set data structure. To keep it consistent, let's once again start with the characteristics. First, a set is a data structure that can hold a collection of values. The values, however, must be unique.
Ah, okay.
Sets can contain a mix of different data types. You can store
But each... Okay. So it's different from an object because the values must be unique. Can hold collection of values. Values must be unique. Can contain different data types.
strings, booleans,
Hello,
numbers,
hello.
or even objects
Soul of
all
Aditya,
selected.
Tarunda.
Third,
I am
sets are
currently
initialized.
learning data structure in JavaScript.
You don't have to declare the size of a set before creating it. Fourth, sets do not maintain an insertion order. An item inserted first does not necessarily mean it is the first element in the set. Finally, sets are iterables. they can be used with a for-off loop. Now, a lot of these characteristics are
Okay, what? Yeah, okay.
similar to arrays. So let's zoom in on the differences. First, arrays can contain duplicate values, whereas sets cannot. Second, insertion order is maintained in arrays, but it is not the case with sets. Finally, searching and deleting an element in a set is faster when compared to arrays. Alright, now that we understand the characteristics of sets and how they differ from arrays, let's head over to Replit and look at an example in code. To create a new set, we use the set constructor.
So there is a set object or constructor already, right?
Const set is equal to new set. The constructor optionally accepts an array as its argument. Let's pass in an array of 3 numbers. To log the values, we can use the for-off loop to iterate over the set. For const item of set console log item. If we run the code, we can see the values in the console. To add a new value, we can use the add method. So set.add and we pass in 4. Run the code and we see the 4 values. If you try to add a duplicate value, the set will ignore that value.
Oh, okay.
So if we add 4 again, rerun, we see 4 only once in the console. If you want to check if a value exists in the set, you can use the has method. Let's change set.add to set.has4. Console log it, and we see true logged in the console. To delete a value from the set, you can make use of the delete method. So set.delete 3, rerun, and we don't see 3 in the console. If you want to check the number of items in the set, you can use the size property. So console.log set.size, run the code, and this will return 3. Finally, to delete all values in the set, we can make use of the clear method. So set.clear. Run the code, and we see no values logged in the console. This pretty much is about the set data structure in JavaScript. In the next video, let's take a look at the map data structure.
So when do we need to use set compared to array?
Data structure, let's look at
So when you don't need duplicates, so does that mean... Okay, let's just ask. Who shall we ask today? Let's ask Perplexity. It's been a while. Hello. Oh, I am from Indonesia. When should we use set or array in JavaScript? Okay, use an array when you care about order, index, and duplicates, and use set when you care about uniqueness and fast membership checks. You need an ordered list. Ah, see, okay. Yeah, definitely for ID, email, or tags. Okay. Duplicates. I always forgot the ... like spread thing, you know? Add packs and shareable into individual elements. Spread can pass array elements as separate arguments. I see. Okay. Okay. So it's just gonna put all all of them separate. Okay. Okay, yeah, I remember this. User equals that, and user copy is just copying everything, which is gonna be the same value. Okay. Override properties. Okay. Okay, if you want next time is also where you can get results. Yeah, okay, later, yeah. Next. Map.
First, a map is an unordered collection of key-value pairs. Both keys and values can be of any data type. Second, to retrieve a value, you can use the corresponding key. Finally, maps are iterables. They can be used with a for-off loop. A lot of these characteristics are similar to objects. So let's zoom in on the differences.
I'm from Indonesia. I just graduated from electrical engineering and currently looking for job.
Objects are unordered, whereas maps are ordered. Keys in objects can only be string or symbol type, whereas in maps, they can be of any type. An object has a prototype and may contain a few default keys, which may collide with your own keys if you're not careful. A map, on the other hand, does not contain any keys by default. Objects are not iterables, whereas maps are iterables. The number of items in an object must be determined manually, whereas it is readily available with the size property in a map. Finally, apart from storing data, you can attach functionality to an object, whereas
An object has a prototype and may contain a few default keys, which may collide with your own keys if you're not careful. A map, on the other hand, does not contain any keys. Okay, what are the default keys of an object? Ugh, okay, man. Starting to get tired.
maps are restricted to just storing data. Alright, now that we understand the characteristics of maps and how they differ from objects, let's head over to Replit and look at an example in code. To create a new map, we use the map constructor. The constructor optionally accepts an array as its argument. The array, though, should contain arrays of length 2 as elements. A, 1, B, 2. Here, A and B are keys. 1 and 2 are the corresponding values in the two key-value pairs. To log the values, we can use the for-off loop to iterate over the map. For const key, value of map console.log backticks key colon value. If we run the code, now we do have an error here since we have to wrap our two array elements inside square brackets.
Okay,
so the
interesting.
Accepts one array which has smaller arrays of length 2 as its elements. If we now run the code, we can see the values in the console. A is the key, 1 is the value. B is the key, 2 is the value. We have two key value pairs. To add a new value, we can use the set method. So map.set, key is C, value is 3. Now this is a method and not the set data structure from the previous video. Please do not get confused.
This is going to be confusing, definitely.
And we see the 3 values. If you want to check if a key exists in the map, you can use the has method. So console.log map.has a, run the code, and we see true logged in the console. If you want to delete a key value pair from the map, you can make use of the delete method. So map.delete C, run the code, and we now have only 2 key value pairs. C has been deleted. If you want to check the number of key value pairs in the map, you can make use of the size property. So console log once again, but this time map.size. Run the code, and this will return 2. Finally, to delete all the key value pairs in the map, you can make use of the clear method.
So yeah, it's quite similar, yeah.
Map.clear. Run the code, and there are no key value pairs in the console. Alright, I hope you now have a fundamental understanding of the built-in data structures in JavaScript.
I guess it's just a matter of...
with the core part of the series, which is custom data structures. And we are going to start with the stack data structure.
Okay, I think we're going to stop here. Is there like a JavaScript DSA practice? Okay. Okay, so which one do I have? I have this one, right? This is the one I have done. And JavaScript. Okay, check the values, objects. Maybe we can go to objects. Object is a fundamental structure so to store, organize, selected data. You can think of an object as a container that holds various pieces of information, much like a filing cabinet holds different folders and documents. These pieces permissions are called properties, and they consist of a key value. Incredibly versatile and form the backbone of JavaScript. In fact, almost everything in JavaScript is an object or can be treated as one. This includes arrays, functions, or even primitive data types like strings and numbers when used in certain ways. These objects are the nature of JavaScript. It's one of the reasons it's such a flexible and powerful language that looks at how you can create an object. Hello, hello, Saw. Hello, hello, welcome. Okay, so yeah, we've created an object called person. It has this key value pair, blah, blah, blah. It's the most common straightforward way to access it. Yeah, notation is concise and easy to read, making it the perfect choice when you know the exact name of the property you want to access. Bracket notation allows you to access object properties using a string inside square brackets. You could do person, yeah, like that. Bracket notation is more flexible than row notation because it allows you to use property names that aren't valid JavaScript identifier. For example, if you had a property name with spaces or the represent number, you need to use the bracket notation. I see, that's what the video meant. Another advantage of bracket notation is that it allows you to use variables to access properties dynamically. Cool. Wonderland person property name. Okay. I see if... Okay, so. Thanks, man. Thank you. All the best to you too. And if I'm not mistaken, isn't it like 3 a.m. in India? particularly useful when you don't know the exact property name. It contains not just simple values. No. Okay. Which notation would you use to access a property of an object if the property name contains spaces? Then we use the bracket. What is bracket notation over dot? This variable name has property names. It's only way to access it's no, yeah, I think that one. Why is it set to be the most things? Because everything in Java has properties and method. Yeah, okay, nice. There are several ways to remove properties from an object, with the delete operator being the most straightforward and commonly used method. When you use delete, it removes the selected property. Okay, person.job. And it's just undefined because just remove this. Person object. Here we go. We have the spread. To remove the job property. The person object no longer has the job. Another way to remove properties by using the structuring assignment with rest parameter. This approach doesn't actually delete property, but it creates a new object without the specified properties. So it's just gonna take the job and the city, and the remaining properties is not anymore. Okay, how does it only take that then? Hey, hello Aquib. Hi bro, hope you both get placed. Yeah man. Hopefully we could get interview at least, you know. Okay, so it's just gonna put it in this remaining properties object. This creates a new object with the job and city. Okay, understanding how to remove properties from object is an important skill. Okay, what will be the output of the code? Okay, we have this will be B, it's gonna remove this, so it's just gonna be A1 and C3 because yeah, it's just gonna remove it from that object. What will be the output? Yeah, so it's gonna be brand, it's gonna be undefined because we deleted that. Which operators commonly used to remove properties? Delete. Nice. In JavaScript, there's ways to check if an object has specific property. Looks for the common has own property method. The in operator and check against undefined. Let's start with the has own property. Boolean indicating whether the object has the specified property. We have an object called person with properties name and age. To check if name is a property, we use as a property. Since name is a property, it will return true, but when we use the has own property to check if job is a property, and okay, this property, just property. In order to check for the existence of a property in object is to use the in operator, name and person. Okay, so that's pretty easy. Look like Python code actually. Yeah, quite similar, I guess. Yeah, okay, just if it doesn't, okay. The following code, it's gonna be true. What will be the output of the following code? It's gonna be true, yes. See, sorry, false, because it does exist.
Thank you for watching. Please do consider subscribing to the channel, and I'll see you in the next one.
Okay, let's just continue with the recode cam, because why not? Okay, I think for the We can do this sometimes another day, maybe tomorrow. Let's do the other data structure tomorrow. For now, let's just continue this. How do you work with assessing properties from nested objects? Do you... Okay. Okay, so it's just gonna be deep inside of that. Okay, so person.contact.phone.work. Okay, yeah, that is correct. You can also use bracket notation. Please don't properties name include spaces or characters. I see. Okay. Cool. Now let's take a look at how we can access data where one of the object possesses the value of an array. Oh. This is more for present inclusive object. Okay. So the person has an address property, but it's an array. I see. Okay. So we can use the index of that array, right? That makes sense. Person, we grab the address of the person, the property, and then we grab the number 1, which is this of the array, and the city is going to be any town. Oh, sorry, yeah, index 1 is this one, because array is 0 index. Of course, I just already forgot the material. So if you want to use the work phone, it's going to be person dot contact dot phone, person dot contact dot phone dot work. Person dot contact. This one could also work, but yeah, let's see. It's probably, if this is wrong, then okay, it's okay. Person contact phone work. Person details hobbies. It's gonna be swimming because the number 1. What will be logged to the console? Data results number 1. It's gonna be Bob. Oh, okay, we're correct. Nice. Create an independent copy of the value. Any changes made to the original value do not affect the copy. Number 2. Non-primitive, on the other hand, are more complex. These objects, which includes regular objects, arrays, and functions, can hold multiple values as properties or elements. When you create a variable with non-primitive value, what's stored in the variable is actually a reference to the location in memory where the object is stored, not the object itself. This leads to some important difference in behavior. Example with non-primitive data types. Copied person, original person, age 31. You can change that, right? You have an object called original person with 2 properties. We then assign the original person object to a variable called copied person. Then we update the age. When we log the age property, it shows the updated value. But why is this happening? This is because both original person are referencing the same object in memory. When you assign an object to another variable, you're copying the reference to the object, not the object itself. Okay, this is confusing. This is known as shallow copying. As a result, any changes made to the object through one reference are reflected Okay, this is confusing. It's considered work with JavaScript, but you can throw a general understanding the difference between primitive. It's a fundamental concept that underlies many aspects of the language and is key to writing efficient and correct code. It's not primitive, it is array. When you assign a primitive value to a variable, the value is copied, right? Yes. What will be the output of the following code? Yes, okay. In JavaScript, functions and object method are both ways to encapsulate reusable code, but they have some key differences in how they are defined, used, and the context in which they operate. Understanding these differences is crucial. Reusable blocks of code. Object method, on the other hand, are functions that are associated with an object. They are defined as properties of an object and can access and manipulate the object's data. Say hello is a method of the person. So that is the properties of the object name. You will learn about this keyword in future lesson. A difference between functions and method is how they are invoked. Functions are called by their name, while methods are called using the notation the object they belong to. Is the context in which they operate in reference to any particular object. Methods, however, are bound to their object and can access its properties. A key point to note is that methods help in organizing code into logical objects, while functions are used for more general reusable code. Understanding the difference between functions and object is important as you progress in your JavaScript journey. Given the following code, how would you correctly call the greet? So it's gonna be person.greet with this square, yeah, this one. What will be the output of the following code? Say hello. Also, first it's going to say hi there. Nine. Say hello. So it's gonna be hello. Hello first. This one first, because it's to say hello. It's standalone. And then hello, hi there. Hello, hi there. Nice. We will take a look at how to work with object. The object constructor creates new There we go. Object. Nice. Okay. Oh, okay, working with JSON. Okay, maybe we can, I don't know. I only like, okay, 150 out of 1000? Are you freaking serious? Okay, this is insane. Even I haven't finished the variables and strings. Because there's just so much. But we need to complete the 5 record bodies to qualify for persistent certification. Okay. I think we can go. I think yeah. Next part we will either go through this or build another project. But I guess that's it for today. Thank you again for everyone watching. I hope everyone have a great day, night, afternoon, evening, wherever you are. I once again I'm sorry. I was not live for almost 2 weeks. It was because I was sick and I just didn't have the energy or like the will power to break through that sickness and just force myself to code and think because yeah, that was pretty bad. Well, not I don't need to go to hospital or anything, but it's just that I can't really think or do anything properly when I was sick. But yeah. Again, thank you very much. Thank you very much for watching. Yeah. And please check out the server and the Discord, and you can share more in there. I think we should make, I don't know, like share IDE, share your experience. Like, I think Alfie made like the Linux or like distro channel. Maybe you can make like editor channel as well, so you guys could share like your config. You guys could share your workflow, any terminals, any tools. I think that would be interesting. So yeah. Thank you, Talnid and Aqib and anyone that is still currently here. I couldn't really see everyone, but thank you for joining and learning with me tonight. See you guys again tomorrow or any other day in the upcoming weeks, hopefully. I'll try to at least have another one stream this week, okay? No promise, but I'll try, okay? Okay. Hope everyone stay safe, stay healthy, and yeah. See you, if not tomorrow, some other day this week.